see about the temperature coefficient of zener diode. Okay, so what is this temperature coefficient? Actually, this is indicating, okay, the percentage change in the zener voltage for each degree Celsius change in the temperature. So it's some constant. Okay, temperature coefficient is a value, it is a constant value, it is a value. Okay, so from that we can understand that if there is 1 degree Celsius change in the temperature, the correspondingly there will be change in the zener voltage. Okay, that is being specified by this temperature coefficient. So it is an indication of how much percentage change will be there in the zener voltage for every degree Celsius change in the temperature. Okay, so in other words we can say if the temperature changes, automatically the zener voltage will be changing, but that corresponds to what? This temperature coefficient value. Okay, depending upon the temperature coefficient value, if temperature changes, then the zener voltage also changes. Okay, so that is the concept of this temperature coefficient. So the change in the zener voltage change, so usually the change will be indicated by what? The change will be indicated by del sign. Okay, change in the zener voltage. So that's what here it means. So del Vz means change in the zener voltage. So that is equal to originally what is the nominal voltage or normal voltage of the zener Vz multiplied by this temperature coefficient, okay, Tc, then it is multiplied by change in temperature. Okay, that's what the formula. So if you want to find out how much change will be there for the zener voltage, then we should know the nominal zener voltage multiplied by the temperature coefficient, and it is multiplied by the change in temperature. Okay, so Vz is what? Nominal zener voltage at 25 degrees centigrade. This is important. So at room temperature, what is the value of the zener diode voltage? Then Tc is the temperature coefficient. Then del T is, del means change. Okay, so change in temperature from the reference temperature. That's what this del T means. So we can have two types of the temperature coefficient values. One may be the positive temperature coefficient, another one is the negative temperature coefficient. So what is meant by positive temperature coefficient? As the temperature increases, zener voltage also increases, then we call this as a positive temperature coefficient. If the temperature increases then and the zener voltage decreases, means it is a negative temperature coefficient. Okay, so the negative temperature coefficient means as the temperature increases, Vz or zener voltage will be decreasing. Okay, that is the indication of this. Now we see one problem. Suppose 8.2 volt is the zener diode, and 8.2 volt zener diode has a positive temperature coefficient of 0.05% per degree Celsius. What is the zener voltage at 60 degrees centigrade? This is the question asked. So we should know that this 8.2 is the voltage is 25 degrees centigrade. It's the normal. Okay, nominal temperature. Nominal temperature we have this nominal value. At room temperature we have this nominal voltage of 8.2 volts. That is Vz. Immediately we have to write it as Vz. So the temperature will be changing to 60 degrees centigrade. Okay, and the positive temperature coefficient is given. So as temperature increases, the Vz also increases. That is the concept. Okay, yes, the Vz increases. So for 1 degree change, if there is 1 degree change, then Vz will be changing how much percentage? 0.05 percentage change will be there in the Vz. If 1 degree temperature changes there, understand? If the temperature changes 1 degree, then Vz will be changing how much? 0.05 percentage. This is given in your problem itself. Okay, And then for 60 degree centigrade, which is changing from 25 degree centigrade, how much actually change in the temperature? We have to notify the change in temperature. This is change in temperature. We need to calculate, that is del T we have to calculate. So the del T is equal to 35 degree. Okay, very simple there. So change in temperature is del T, that is 35 degree. If 1 degree change is leading to 0.05 percentage change in the Vz, then for 35 degree we have found out that del T is how much? We have found out that del T is 35 degrees Celsius. So for 1 degree Celsius we have this 0.05 percentage change in Vz. Then for 35 degree, how much change will be there? For that we can use this formula. Del Vz is equal to Vz into Tc into del T. Okay. So we can substitute the values as such. Vz is given in the problem, we know, right? Vz is given in the problem itself. What it is? It is 8.2. So that 8.2 is available here, multiplied by temperature coefficient is given as 0.05 percentage. Okay, so into 100 we have to put. Then del T we have found out it is 35 degrees Celsius, so 35, right? So in total we have 144 millivolt, that is equal to 0.144 volts. Okay, then we can find out the new Vz. New Vz is zener voltage is equal to 8.4, that is the original voltage, plus 0.144. So new Vz is equal to 8.344 volts. So yes, we complete.